Alright, welcome to multiplying rational expressions. I find this to be a bit easier than the addition and subtraction of rational expressions, mainly because we don't have to find a common denominator. Yeah, we can just multiply, just like when we were multiplying our square roots. So much easier. I also like these because they're like a puzzle. There's so many different ways that you can finish a problem, and getting there really causes you to think, okay, this works, that doesn't, so on and so forth. So let's jump right into it. And going right into that, different methods of solving, getting the same answer. That's what we have right here. We have two of the same problem. We're going to solve them different ways. We're going to get the same answer. So let's start on the left. Now, because we're multiplying, that means that when we reduce our fractions, we can reduce within the same fraction, or we can reduce diagonally. And we can do that at any point. We can reduce in the same fraction and then reduce diagonally, just keep reducing the same fraction until we're done, so on and so forth. So there's many ways to solve these. And the main reason that we want to reduce it completely before we actually multiply is because it saves us time after we multiply reducing. Because if I were to multiply 70 and 25 together, that's going to give me a pretty big number. So if I were to reduce it, it makes that number a little bit easier to deal with. And it means that after I'm done multiplying, I don't have to reduce anymore. So I'm going to reduce this 70 and this 42. 70 and 42, I know they're both multiples of 7. So I can divide these both by 7. 25 and 40, I can divide those both by 5. So 70 divided by 7, 10. 42 divided by 7, 6x. 25 divided by 5 is 5. 40 divided by 5 is 8. Okay, I'm going to stay in the same fraction. I can divide 10 by 2 and 6 by 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. Times 5 over 8. And we haven't been able to do anything with that x. It's just been following along because there's no other x's to reduce it with. So we look. Can I do anything diagonally? Doesn't look like it. Can't reduce anything diagonally, so we just get to multiply across. So we're going to multiply across. 5 times 5 is 25. 3x times 8 is 24x. So it looks like we reduce it, multiply and reduce, and we get 25 over 24x. Let's see if we can get the same thing over here. We're going to start out by reducing diagonally. So let's reduce diagonally. 70 and 40. Those both divide by 10. And it looks like we can't reduce the 25 and the 42. That's alright, it'll happen. So 70 divided by 10, 7 over 42x, times 25 over 4. Still can't do anything else diagonally, so let's look in the same fraction, this 7 and 42. Well, they're both divisible by 7, so we're going to divide by 7, and we get 1 over 6x times 25 over 4. We cannot do any more reducing, so let's multiply across. 1 times 25, 25, 6x times 4, 24x. Hey, it worked out. That's good. That means we didn't make a mistake. Hopefully. So, that's just to show you, hey, there's multiple ways we can solve these. So let's jump right into solving. So here's a couple examples. And we look, okay, there's many ways that we can reduce. We can reduce the 6 and the 4. We can reduce the 6 and the 10. Numbers wise. We also look here, we have an x plus 2 and an x plus 2 being multiplied. Well, we can reduce those. So luckily our x plus 2's go away. And I'm going to just reduce the 6 and the 4. So we're going to divide those by 2. because over here we have this 5 and the 10, which we can also divide by 5. So divide by 5, divide by 5, we're going to divide by 2, and we're going to get 6 divided by 2 is 3, 4 divided by 2, 2, times 5 divided by 5 is 1, 2, x minus 3. Looks like we can't do any more reductions, so let's multiply across. 3 times 1 is 3, 2 times 2 is 4, x minus 3. Over here on the right, we have 9 times r plus 5 over r plus 2 times 4r divided by 3r plus 15. Well, if we look here, you notice something hopefully about this 3r plus 15. We can factor something out of that. We can simplify that. So let's factor out a 3 there and rewrite it and then take a look. So we're going to 9r plus 5 over r plus 2 times 4r. We factor out that 3, we see we get another r plus 5. So alright, when we factor and make sure that we have everything factored out, simplified out, we can actually look at this and say, okay, this will reduce, this won't. So we looks like diagonally we can reduce this r plus 5 and this r plus 5. This 9 and this 3, we can divide those by 3. And that looks like that's all we can do. So 9 divided by 3 gives me 3 over r plus 2 times 4r over 1. Looks like everything reduced right here. So everything reduced right there, so we're just left with 1. So now we get to multiply across. 3 times 4r, 12r. r plus 2 times 1, r plus 2. There we go. Alright, here are 2 examples for you to try on your own, so go ahead and pause the video and try them now. Alright, here are the solutions to those problems, so go ahead and check your work with mine, and here's something you need to remember. The work that I do may be different than the work that you do to get to the answer. The goal is we get the same answer. If our answers are different, then there's something wrong. Then you made a mistake somewhere, or I might have made a mistake somewhere. So, don't check the work to see did I do everything the teacher did. Say, did I get the same answer? If not, why? So, one more example, and then you get to do another problem. So this one's just a little bit harder example because we have to factor a quadratic. So, nothing else will reduce until we factor that quadratic. So let's go ahead and do that. So we have 27 and we want to get a, well, that says 24. 27 and we want to get a positive 6 from 27. Well, I know 3 and 9 is going to work. Negative 3, positive 9. So we rewrite 1 over x minus 9 times x minus 3 times x plus 9 over x plus 9. So I took that x squared plus 6x minus 27, changed it into x minus 3 times x plus 9 by factoring. And it looks like our x plus 9s will reduce. So 1 over x minus 9 times x minus 3 over 1, which gives us x minus 3 over x plus 9. There we go. So that wasn't too bad. Alright, so here's your chance to try that. So go ahead and try this example by pausing the video. And here's the solution to that example problem. So go ahead and check my work with yours. Make sure we both got it right. And after you do that, done with this video.